Check it.
Okay, welcome back. Today we're going to be talking about operations on polynomial. A polynomial is a group of, or a sum of, multiple terms, multiple monomials. Mono means one. So what is a monomial? Well, examples of monomials would be 3x, that's a monomial. Maybe x squared, that's a monomial. Maybe 5x to the fourth power, that's a monomial. But when you put a plus in between or a minus in between these, now that's a polynomial. Now, technically, even if you have a single term like 3x, that's a monomial, but it's also considered a polynomial of one term. So a polynomial is one or more monomials. A monomial is a single term that follows some specific rules. They are multiples of x, first of all. So you might say, well, didn't I say a minute ago that 5 was a polynomial? Sorry, a monomial and a polynomial? It is, but that's only because x to the power of 0 equals 1. This is a 1 right here. And if that's a 1, this is just 5 times 1, so it's 5. So even a number like 5, which does not have any x at all, is still a polynomial because technically it's the 0th power of x, okay? So what would make something not a monomial? Well, for one thing, if its power is negative. For instance, if you had 3x to the power of negative 2 instead of positive 2, that's not a monomial. Or if you had something like, 4x to the negative 3. Not a monomial, because your power of x has to be positive. Also, the power of x has to be a whole number. So let's say you had, 3x to the 1/2 power. This is not a monomial. Would this be a polynomial, this whole thing? No, because one of the terms doesn't qualify. So now the whole thing is not a polynomial. You see what I'm saying? One term ruins everything. So basically you're looking out for certain things here. It's a monomial or a polynomial if its power is positive, meaning not negative, and if its power is a whole number. Now, here's the thing. We're going to learn later on in this chapter that is if you have a negative power, like 3x to the negative 3, this is actually the same as having 3 over x to the third. So x is in the denominator. That happens when you have a negative power. We'll talk about that in a few minutes. So if x is in the denominator, that's the same thing as a negative power, so this is also a no. This is not a polynomial, this is not a monomial. Another thing is if your x is inside of a radical. So what we're going to learn in chapter 7 is that if you have, let's say, x to the 2/3 power, x is not, the power is not an integer, not a whole number. That's what integer means, whole number, positive, negative, or zero. If your power is a fraction like this, this is not a polynomial, this is a no. You're on the lookout for negative powers because they're not monomials. If an x is in a denominator like this, then it's not a monomial. Fraction powers, or decimal powers for that matter, or radicals. If your x is inside a radical, which is actually the same as this, okay? And this is the same as this. All right, so those are the things to look out for. So let's just play that game now of is it or isn't it? We'll do that right here. Is this a polynomial? Do we have x's? Well, the last one doesn't have an x, but remember, no x at all means x to the 0. So yeah. Are all the powers whole numbers? This is x to the 4th, yes. This is x to the 1st because there's no power there, so it must be the 1st. So yeah, no decimal powers, no fraction powers. That's good. Are any of the powers negative? No. And are any of the x's in the denominator of a fraction? No. So this passes all 4 tests. This is, yes, a polynomial. Now, if it's a polynomial, what is its degree? Well, look for the highest power of x in the polynomial. It's x to the 4th. So this is a 4th degree polynomial. How about this one here? Well, this is a monomial, 3x to the 0. This is a monomial, 2x to the positive 1. All good there. But this one has the x in the denominator. So this is no good right here. This is not a monomial, so this cannot be this whole thing cannot be a polynomial. How about this next one here? 3x to the 2nd power. That's good. 2 times the square root of x. Now this is an x inside of a radical, just like we said up here, x inside of a radical. And what we're going to learn in chapter 7 is that that is the same thing as having x to the power of 1/2. And once again, no good. That's not a polynomial because of this middle term here is not a monomial, so this is a no. Okay, how about this one here? We have negative 5x squared. The power of x is positive, and there's no radical over the x, so far so good, and the x is not in the denominator. How about here? We have 2x to the 4th over 3. No x's in the denominator, no radicals over the x's, and no negative powers. Negative 3x to the 4th, once again, whole number power, all good. And here we have a radical, but there's no x in it, just a number, okay? Radical 4. Radical 4 is obviously 2, but this could have just as well have been like radical 5 or something. Point is, there's no x here. So if there were an x, it would actually be on the top as x to the 0, and that's fine. So yeah, this is actually a polynomial, yes. And what's the degree? Well, we look for the highest power of x in the whole thing. There's a power of 2 here, there's a power of 4 here, and there's a power of 4 here. So this is a 4th degree, because that will be the highest power. You just look for the highest power in the whole thing, 4th degree. How about here? Well, the power of x is not a whole number. Square root of 5 is not a whole number, so right away this disqualifies the whole thing, and this is a no. And now finally over here. Well, on the top we have 5x to the first power, which is fine, and 2, which is fine. This is 2x to the 0, right? So that's all good, but the problem is we do have an x down here in the denominator, and anytime your x is in the bottom of a fraction, it's equivalent to having a negative power. So this is a big fat no. Okay, properties of powers. So when you have something to a power, let's say we have x to the 4th power, the big number on the bottom is called the base, and the little number up in the air is called the exponent. Hopefully you learned this in Algebra 1, so this is a quick review here. When you multiply two things of the same base, you can add the powers. So here, x times x is x to the 1st times x to the 1st, which equals x to the 2nd. And there's your answer, box your answer. How about over here? X to the 2nd times x to the 4th. Well, this is 2 x's, x times x, and this is 4 of them. So altogether you have 6 of them. Don't multiply the powers. You do not get x to the 8th. Don't multiply the powers, because remember, this is coming from 2 of these, 4 of these, and when you multiply all of these, right, you're just multiplying 6 of them. So you get x to the 6th, not 8th. So be careful. All right, what about dividing? Well, when you're dividing, once again, this x to the 3rd is just x times x times x. And on the bottom, it's x squared, which is x times x. What do you do when you have things on top and bottom? Well, you usually cancel things out. Why? Because this right here is a 1, and this right here is a 1. So all the vertical pairs here cancel out, not because they just disappear, but it's because a fraction whose top and bottom are both the same, rather, equals 1. So yeah, that becomes a 1, that becomes a 1, and you know, for all intents and purposes, they cancel out, and you have an x here, x to the 1st. Now, is there a simpler way to do this without drawing out all the x's? Yeah, pretty much. You just subtract this power from this power. So as when you're multiplying, you're adding the powers. When you're dividing, you're subtracting the powers. You're going to subtract 3 minus 2 and get 1. Well, how about here? 2 minus 3 is negative 1, so you're going to get x to the negative 1. Now, does that make a lot of sense? Well, we're going to have to understand something about negative powers. Let's just take a look at this really quickly. If you took x squared and, you know, expanded it, it's x times x, right? And then x to the 3rd is x times x times x. Now, once again, these two cancel out. These two cancel out. This becomes a 1, this becomes a 1. And 1 times 1 is still 1. So what we're saying is, two things here, that when you have, just a little more room here, when you have something on top divided by something to the bottom, you're supposed to subtract the powers, and 2 minus 3 is x to the negative 1. Okay, so if you look at it this way, it's x to the negative 1. If you look at it by flushing it out, it's 1 over x. These must be the same thing. Therefore, 1 over x is equal to x to the negative 1. And vice versa. X to the negative 1 is the same as 1 over x. Okay, and this is the definition of x to the negative 1 that we're going to use now. So here's the deal. Why don't I just leave the answer as x to the negative 1? Why didn't I stop here when I got this? Because you may not leave any negative exponents in your final answer. Simply put, if you ever give me an answer that has a negative power in it, I'm marking it wrong, okay? Okay, that cake is not baked yet. So anytime you see a negative power, you must change it to a positive power, but you're supposed to do it the right way. So take a look here, number 5. It looks like there's nothing to do, but there is something to do. You have a negative power here. You cannot have a negative power here. So what we're going to do is this. We're going to factor the power here. If you remember, when we did imaginary numbers, every time we had a negative square root, we had like square root of negative 25. I said, make it a positive 25 and put the negative in its own little radical out here. We're going to do the same thing here. This is a negative power. We can't have any negative powers. So what we're going to do is make this a positive power and then put the negative power out here. Now, what did we say about a power of negative 1? It means reciprocal, flip, upside down. So what you have here, you have an x squared with a flip. So that means 1 over x squared. And now you're done. Now notice there are no negative powers, and that is going to get you full credit. You may not leave it with a negative exponent. Okay, let's do a couple more of these so it sinks in. This is x to the negative 5 times y to the 3rd times z to the negative 1. They're different bases, so you cannot multiply them. They're just going to sit there the way they are. However, you can deal with these negative powers. This is actually, right here, This is actually x to the positive fifth to the negative 1. This is y to the third. This one's fine. You shouldn't do anything with that. And this is z to the negative 1, which is the same as regular z with a negative 1. Now, anything that has this negative 1 on it, power of negative 1, gets flipped. So this becomes 1 over x to the fifth. This is fine, so leave it alone. And this becomes 1 over z. When you have stuff that are fractions and stuff that are, whole numbers, just make them all fractions. So put this over 1, make it a fraction, and now make one big old fraction out of everything. And that's going to be 1 times y cubed times 1, so just y cubed on the top. And on the bottom, you have x to the fifth times 1 times z, which is x to the fifth z. And now, this gets you full credit, whereas if you gave me this as an answer, I'd be marking it wrong because you're not done yet. You have to go through this process. No negative powers left in your final answer. How about this one? This is going to get what? Flipped, right? So this is r squared to the negative 1. This is c to the third, which is not going to get flipped. This is d squared with a flip. And this is just p to the 0. So we're going to flip the stuff that has a negative 1 power, right? And eventually you'll just jump over this step and go straight to the answer. I realize that, but just until you understand the concept, I'm showing you every single step. So r squared gets flipped, becomes 1 over r squared. C to the third does not get flipped, so it stays on top. D squared gets flipped to the bottom, and p to the 0 stays where it is. And once again, you're supposed to make one big old fraction out of this. So the stuff that's on the top is going to be c to the third, p to the 0, and on the bottom it's going to be r squared, d squared. In other words, r2d2, c3po. Okay, for you Star Wars geeks out there. Technically, the p to the 0 becomes a 1, so really it's just c to the third over r squared, d squared, but that's not as much fun. So anyway, there you go. How about this one here? Now, there are two ways to approach a question like this. Let's do it both ways just so you understand that it works the other way. If you flip the stuff that can be flipped first, okay? The 2, by the way, this is not, don't think of this as 2x to the third. Think of this as just 2 times x to the third times y. Think of this as negative 7, separate from the x, separate from the y. And now ask yourself, for each one of these, do you get flipped? So, is this a 2 to the negative 1? No. So don't flip the 2. It's fine. The x to the third does get flipped because it's x to the negative third. So this becomes 1 over x to the third. The y to the third is not negative power, so y to the third. And now here, the 7, does it have a negative power on it? No. So leave the 7 alone, negative 7. X to the fifth, also positive power, so leave it alone, no flipping there. But y to the negative 6 is the same as 1 over y to the 6, like that. That got flipped. And now when you simplify these, every one of these becomes a fraction, where the bottom, okay, remember, these are tops, and these are bottoms. The tops here are 2y to the third, and the bottom is x to the third. Here it's negative 7x to the fifth on top and y to the 6 on the bottom. And now you can multiply. How do you multiply two fractions? You just multiply the denominators and the numerators. So you're not done because this thing is not simplified. There's no coefficient here, but it's a 1, right? So you have negative 14 over 1. Can you reduce that? Not really. It's already over 1. But you have x to the fifth over x to the fifth over x to the third. You can subtract the powers there, right? Like we did above. And here you have y to the third divided by y to the sixth. You can also subtract the powers here. Okay? So you're supposed to, here's what you're going to do for these. Whenever you have a problem like this, what you're going to do is chop this up, numbers, letters, right? And do each one of these individually. So negative 14 over 1 is still negative 14. X to the fifth divided by x to the third, you're going to subtract the powers and get x to the second. And y to the third divided by y to the sixth, you're going to subtract the powers and get y to the negative 3. And now you realize, uh-oh, I got another negative power. I have to flip that. And this becomes negative 14x squared on top. The y to the third gets flipped to the bottom. And there's your answer. Now, technically, the negative shouldn't be on top or bottom. Now, I did say that we can do this two different ways. So what if we did it the other way? What if we took this here, copied it, and did number 8a, as it were? Put this over here. How could you do this without doing all the flipping first? Well, you could just multiply. So what's 2 times negative 7? Negative 14. What's 2x to the negative third times x to the fifth? Now, when you're multiplying two things at the same base, you're supposed to add the powers. So what's negative 3 plus 5? It's 2. Y to the third times y to the negative sixth. Add the powers. 3 plus negative 6 is negative 3. And you can see these are identical. And that was significantly less work, by the way. That was a lot less steps. So you make up your mind how you want to do this, but I think flipping at the end is the best bet. because flipping at the end means you don't have to simplify twice. So you end up getting the exact same answer here. Okay, now we have this one here. This is a fraction to a power. And when you have a fraction to a power, you have to take the top and bottom to that power. For instance, give you a little example. Let's say you had, I don't know, 2/3 to the power of 3. What does that mean? It means 2/3, okay, times 2/3 times 2/3, right? And when you multiply them, you get 2 to the third power, because 2 times 2 times 2. And you get 3 to the third power, which is 3 times 3 times 3, right? So 2/3, a fraction to the third power, is the same as 2 to the third power over 3 to the third power. It's kind of like thinking of it as almost distributing the power to the top and to the bottom. So now we have this. We have a over 4 to the negative 3. So this is going to be a to the negative 3 and 4 to the negative 3. Now, who gets flipped? Well, actually, they both get flipped because they both have a negative power, right? This is a to the third with a flip, right? Let me do the flip in red here. And this is 4 to the third with a flip. Flip means if you're on top, go down to the bottom. If you're on the bottom, go up to the top. So they're going to trade places is what's going to happen. The 4 to the third gets flipped up to the top, and the a to the third gets flipped down to the bottom. Now, 4 times 4 times 4 is 64. So if you really want to go all the way, there it is. That's your actual answer right there. All right, one more of these. 15 c to the 50 to the third divided by this. Now, chop this up. Numbers, letters, other letters, constants, c's and d's, right? What's 15 over negative 3? It's negative 5. What's c to the 5th divided by c squared? You subtract the powers, you get c to the 3rd. What's d to the 3rd divided by d to the 7th? You subtract the powers, you get d to the negative 4th. And once you're done, you look, say, do I have any negative powers here? Because I can't leave any negative powers. Mr. Abdulhadi is going to take away a bunch of points. Well, yep, there's one right here. So this gets flipped. This is the same as, remember, d to the 4th with a flip. So this becomes negative 5, c to the 3rd, that's all on top, over, and this, what gets flipped is the d to the 4th. And now, like I told you, technically the negative should not be on the top or the bottom. The negative should be in the middle for the whole fraction. So this is your correct answer right there. C, operations on polynomials. Okay, so now that we know about negative powers, we can go ahead and just review something else from Algebra 1, which is adding, subtracting, multiplying, and dividing polynomials. Adding and subtracting polynomials is literally just combining like terms. It's like, for instance, here, 3b over here. You have 3x squared plus, minus x plus this thing here. Well, you're only going to be able to add and subtract things that are of the same power of x. So 3x squared plus anything over here ain't going to work, right? So the parentheses really don't do anything in this case here. So you can pretty much just drop the parentheses. Plus negative is just minus, so I'm not going to put a double sign there. You have these three things here and just combine like terms. The only like terms are the negative 6 and the 1. So you get 3x squared minus x minus 5, and you're done. Now, you want to put your polynomials in order of descending power, the highest power followed by the next lowest until. So this is x to the second power, this is x to the first power, and this is x to the 0 power, meaning no x at all. How about this one here, subtraction? Can I just drop the parentheses like I did here? The answer is sorta. You can drop the parentheses on the first one, but because there's a negative in front of this set of parentheses here, okay, unlike here where there was a positive, because there's a negative, you're subtracting all of these. So you have to actually distribute a negative to all of these. So this is minus x squared, so minus x squared, and then minus 2x and minus 5. So you're distributing that negative first. And now, once you've done that, now you can go ahead and just combine like terms like you did over here. So the difference between adding two polynomials and subtracting is that whatever you're subtracting, you need to distribute that negative first. And now let's see, we have an x squared here and x squared here. They're both negative. Negative x squared plus negative x squared is negative 2x squared. There's two of them. Negative 3x and negative 2x is negative 5x. Positive 4 and negative 5 is negative 1. And there's your final answer. All right, that was adding and subtracting. Multiplying comes in all different kind of configurations, shapes and sizes. Multiplying, if you have one term times like three things here, well, this is called distribution. Once again, all this is Algebra 1, so just a little bit of review here. So if you have one monomial times a trinomial, you're going to distribute the monomial to each monomial inside the trinomial here. And what do we get? 2 times 3 or 3 times 2 is 6. And x to the first times x to the second, you add the powers, you get x to the third. 3x times negative 4x. 3 times negative 4 is negative 12. X to the first times x to the first, you add the powers, you get x to the second. And then 3x times 6. 3 times 6 is 18. X to the first power, x times x to the 0 power. I know it's not written there, but that's an x to the 0 power. And you add the 1 here to the 0 here, you just get x to the 1. So it's just 18x. Okay, this last one is a trinomial, 3 terms, times a binomial, 2 terms. Now, when you see 2 sets of parentheses, you might think FOIL, right? Like x plus 5 times x minus 7. We're not going to talk about FOIL because we know how to FOIL already. FOIL was a way to multiply 2 binomials. And it was a reminder not to just multiply, because some people would just go x times x is x squared, and 5 times negative 7 is negative 35, and think that they were right. In fact, they were actually very, very wrong. So it was a reminder that you were going to distribute your first term completely and then distribute your second term. And they called it first, outside, inside, last. But really, you're just distributing each term in the first polynomial to each term in the second polynomial. And the whole idea of first, outside, inside, last falls apart if you don't have a binomial times a binomial. Well, what about 3 by 2? This is 3 times 2. Well, distributing still works, but FOIL does not work here. In other words, if you're going to distribute, let's distribute that to everything here. N squared times n to the first is n to the third. Okay. N squared times 2 is 2n squared. Right? And now we're going to distribute the middle term. Boom, boom. 4n times n is 4n squared. And 4n times 2 is 8n. And then finally, we're going to distribute the negative 6. Boom, boom. Negative 6 times n, negative 6n, and negative 6 times 2 is negative 12. So distribution works no matter what size polynomials you're multiplying. And as long as you don't call it FOIL, it'll work no matter what. But just remember how you're doing this now. Okay, so once you get to this stage here, you need to combine like terms. So do we see any like terms? Because if you box this, you're only getting 2 out of 3 because you're not done simplifying. So there's only one n cubed. So bring it down. These are n squareds. They're the same power, so you can add them together and you get 6n squared. Now these are like terms, 8n and negative 6n. When you add those, you get 2n. And there's a lonely 12 on the end. Bring that down and we're done. Notice my powers go from 3 to 2 to 1 to n to the 0. That's a polynomial. All the powers are positive or 0, and they're all whole numbers. So this is a polynomial. Okay, we are done. See you at the next video.
Check this.